Okay, this is a video of Robbie's invention. What do you name the invention?
The light alarm.
The light alarm, okay. Okay, we need to take that again. Yep, he knows why. Okay, this thing's supposed to be turning lights on. Okay, wait.
Wait, 10 seconds.
Dun da da da. It goes a little bit longer than one full cycle because we did it based on 2 seconds, which is how long it took last time, but now it only takes 1.5 seconds because it has fresh batteries. Oh well. So Robbie, what do you think about this invention?
I kind of like it.
Tell us about it.
It's pretty useful. It's like when your alarm clock goes off, it's got a microphone here that senses your alarm. You know, and this turns on and turns on your lights so you can wake up easier if you're a tight sleeper like me.
So tell me about making the circuit. What did we do?
Took a lot of parts. It was fun to make.
What kind of circuits does it have in it?
556 chip. It's got.
Tell us about the 556 chip.
The 556 is like 2 555 chips, but it's the ground and the VCC are shared.
Okay, what else about it? About that circuit?
And it's like a timer chip.
What do those timers do?
Make it 2 seconds.
Make it spin for 2 seconds. So why do you have two timers then?
Because we need like a 10-second timer and a 2-second timer.
What's the 10-second timer for?
Like 10-second pause after your alarm goes off, so it doesn't waste the battery.
Doesn't keep running.
Keep running.
So it doesn't keep running on every pulse of the alarm. Beep, beep, beep.
End up here, and so you can't turn it off. Though you can manually do that.
Yeah. So really, the 10 seconds is just to ignore the alarm for 10 seconds after it runs the first time. Okay, clap again and show that. Okay, that's running. Keep clapping. Keep clapping. So it's ignoring all sound input for 10 seconds. And it runs again. Dun da da da. Okay, so tell us about other circuits. What other circuits are there on there?
It's got a relay.
What does the relay do?
It switches. It's got like two. It's like disconnecting and reconnecting a wire.
The motor wire
so
itself?
It's like 2 wires here and 2 wires here.
Uh-huh.
If it's connected, flip to there, then those wires are connected. Flip to there, those wires are connected.
Okay. So actually it only has one input. And that one input is connected to one side or the other depending on which way the relay pulls it.
Turns it on.
So what are we using it for? What's your circuit using it for?
It's for the motor.
To physically connect the motor wires together?
Yeah. When it will connect the motor wires together so it can turn on. It's got VCC and VDD.
Okay.
There and then A and B.
So these two wires are physically connected together by the relay. We had to hook it to there because this wire didn't quite stretch clear to there. So there, this brown wire goes into the relay, and then those two get connected when the sound is made. Okay, so what other circuits are there? There
is a microphone and some little chiclets. No, just kidding.
Capacitors that look amazingly like chiclets. Robbie has resisted the urge to eat them.
With a resistor.
Yeah. What do those do?
Well, they're capacitors.
They're capacitors, but what does the whole circuit do? These 3 transistors and the capacitors.
It's like a NOT gate right here.
Well, no, these are the NOT gates. Remember this? Remember how this only puts out 3 millivolts?
Yeah, there's 3 millivolts.
We need a lot more than that to...
We need, capacitors and resistors.
Okay. To do what?
Because we only need 1 volt.
We need 1 volt, and it only comes out as 3 millivolts from the microphone. So what's that doing?
So those are storing
amplifying it. Well, they're amplifying the voltage up higher.
Yeah.
So it's high enough to trigger the rest of our circuit. And it also does some things like it triggers, it detects when the sound's falling. So, and then as Robbie was talking about the NOT gates, we created our own OR gates, 2 of them, and our own NOT gates, because we didn't have the right chips to do it, which actually I think is better. It's so easy. Simple transistor, and you got a NOT gate. So,
potentiometers for the microphone.
oh yeah, potentiometers. So what do those do?
So yeah, if you turn it down, then you'll have to make a louder noise to turn that on.
Yeah, so this one's a sensitivity, which we got cranked all the way up. This one is a amount of power going out as a baseline. You can raise it higher and lower.
So if it's like low at the very
end. So I don't think... Here, we'll do this all the way sensitive, but not enough voltage going out. That's as much as we need to do it there. And then you can change the sensitivity. Probably could figure out, we should probably figure out what those values are and replace them with resistors in the circuit. Because we have it all the way sensitive and we want that just at some level that doesn't change. So we should probably just keep it where it's at some point. You clap again, make sure that's still working. Okay.
50K.
Well, 50K is the total.
Yeah, 0 to 50?
I think it needs to be in the 40K range to work. And this one needs to be all the way down. We need it as sensitive as possible. Since that mic doesn't put out a lot.
And we also got holes here.
Oh yeah, we
this is a KNEX molder. Or KNEX.
So we've drilled holes into a light switch panel. And that's where the KNEX motor goes in. So anyway, that's the thing. What else would you need to do, would you want to do on this project?
I would probably want to have a circuit board instead of a breadboard and have a cover.
Yeah. And less electrical tape probably, huh?
Yeah. Less electrical tape. And maybe sell a product.
You think so?
Get sponsored.
Can you clap, make sure that's working?
Is it up?
Yeah, it's up. Okay. I want to make sure it's running. I have to keep doing that after we do that. And we've taped this, like our taping job, taped the battery down there. We had to move our relay was originally on top. Had to get me moved down below so we could tape a motor there. Lots and lots of electrical tape.
This is to make sure that this reaches that, because if it's back, it's going to be down here.
Oh yeah.
It's not going to reach.
There would need to be a certain amount of distance between the bottom of the.
Up to here.
Yeah. Thing had to lean in just a bit, which meant the bottom had to lean out just a bit. Which luckily our breadboard was the right size to do that. Well, that with the batteries at the bottom, it's at the right angle to work. All right. Any last words for the internet?
One more try.
All right. Okay.
Awesome.
Dun-dun-dun-dun. Say bye.
Bye.
One more very important thing we forgot about. What day is today?
It is the 14th.
Of?
Pi Day.
In March.
Oh, of March.
So,
14th.
To celebrate his little invention that's still hanging over on the wall, we made pie. Pickle pie. World famous pickle pie for Pi Day. So happy Pi Day, everybody. We're going to eat some pie.